All right, guys, here we go. In a sense, you kind of already know this a little bit about it, but you just haven't put the math together. But you kind of already know this, for more or less. We're going to talk about a theorem. It's called the Extreme Value Theorem. Relax. The Extreme Value Theorem is one of the easiest ones. All the Extreme Value Theorem says, if you have a closed interval, you have a max and a min. You have extrema. Extrema is Latin for extreme. If you didn't know, it just means extreme values. Cool or not cool? So what are extreme values? Max and mins. Yay? So if you have a closed interval, every closed interval has a max and a min. That's all it says. Now what about if you don't have closed intervals? It's possible, but not necessarily. So all this, let's see what it says. F is called increasing on a given interval for any x1 and x2 on the interval such that x2 is bigger than x1. Okay, that makes sense. You read a graph left to right. F of x2 is bigger than f of x1. So all that means is that your y value is bigger than the previous y value. Cool? F is called decreasing on a given interval for any x1 and x2 on the interval such that x2 is bigger than x1. That means you're reading left to right. And f of x2 is smaller than f of x1. Yeah, that makes sense. That means that your y value at x1 is larger than your y value at x2, meaning you're going downhill. Does that make sense to you guys? This is how they say it in math. If it doesn't make sense to you guys, let me know and I can interpret it to you. Yeah. Yeah, this x2 greater than x1 just means read it left to right. And then this f of x2 is bigger than f of x1 means that at x2, the y value is bigger than x1, meaning you're going uphill. Does that make sense? And then this, again, that means left to right. And this f of x1 is bigger than x2. That means x2 is smaller than x1. So this means you're going downhill. That makes sense? Okay. So again, what do the extreme values say? If f is continuous on a closed interval a to b, then f has both a maximum value and a minimum value on the interval. Closed interval means closed circles. I'm about to do 3 examples. Yeah, but it doesn't mean it's possible you can have a max min, but only on a closed interval do you have a guaranteed max min. So let's see. Closed interval. I'm doing y equals x squared, but I'm talking specifically in my domain 0 to 2. Notice that I put brackets. So closed interval 0 to 2, 0, 2. Does this graph have a min and a max? Yes. Here's your min, lowest point on the graph. Here's your max, biggest point on the graph. Cool? All right, I'm going to do the same function, x squared, but this time I'm going to do my domain from 0 to 2. Notice that I put a parenthesis on the 0. So here we go, open circle. Does this graph have a min and a max? It has a max. Does it have a min? No min. I guess I'll write no min. No. Yeah, because then you're going to say, well, I have a minimum at 0.0001. But then someone's going to say, well, you have a minimum at 0.0000000001. And we can never get close enough to 0 that will say, like, the next quote-unquote pixel is going to be smaller. Does that make sense? All right. So, but that doesn't mean that, okay, well, I'm going to hush because I want to make it a surprise. Does this one have a min or a max? None. No min, no max. Now, we got to be careful. Just because I have open intervals does not mean that you never get a min or a max. Travis, can you give an example? What if I have this? 0, and then notice both endpoints are open circle, right? But does this one have a max? This one has a max right there. Does that make sense? Okay, I'm going to see if we can throw one more curveball at you guys.
So that one has max, no min.
This one has no min, but it has a max. Yeah, you're right. One more curveball. Let's see. Horizontal line. And notice that my intervals are closed. Well, I don't know, Chav. Perfect. Extreme value theorem says, if you have a closed interval, you must have a max and a min. Does that make sense to you guys? So this has max and min at every coordinate. Every coordinate is max and min. Every coordinate is max and min. Your max is whatever that y value is. Your min is whatever that y value is. It stays at that value all the time. So those y values are your max and min. How do we feel? That's all the extreme value says. That's all it says. So what does the extreme value theorem say? On a closed interval, it's guaranteed to have a max and a min. So write that down somewhere. Or I wrote it right here for you guys. If f is continuous on a closed interval a to b, then f has both a maximum value and a minimum value. This right here that I'm circling is your EVT, extreme value theorem. Yeah, don't get it confused with IVT, intermediate. Maybe it's best if we don't even use acronyms. Just use the whole thing.
Is there, so we have an intermediate value theorem, we have an extreme value theorem. Is there like a low?
Well,
like a mean value
there's a mean value theorem, which we're really close to getting. Mean value, yeah, that just means average. All right, are we okay so far, guys? Okay, look at this picture here. There are some words, some vocabulary words that we use interchangeably, and I want you guys to make sure that we know them. Ready? The word local means relative. And you're going to see those words interchangeably. So if it says, can you find me my local mins or local max? It means the same thing as, can you find my relative min, relative max? I think that's pretty easy to remember. Maybe, I don't know. Your relatives, are they local? I guess, maybe. I mean, if they're around here. Well, okay. So I think that's pretty easy to remember. Absolute is the same thing as saying global. And I think that's pretty easy to remember. What is your absolute max? That just means, what is the biggest max? What is the global max? What is the world, like global, the whole world? What is the global and absolute mean the same thing? Local and relative mean the same thing. Are we clear? Okay. So, real quick, we're going to label all these critical points. Oh, I guess I got to tell you what a critical point is. All right. I didn't put it on this definition. It's actually on the second page, but it makes sense to write it here. F prime equals 0 or undefined. Put that in there. This is called critical point. If the derivative is 0 or undefined, it's called a critical point. Why do they call it a critical point? Because there might be something happening there, or there might not. Does that make sense? We're about to label all our critical points. So how do I know when my derivative is 0 undefined? Well, remember, if the derivative is 0, you have horizontal tangents. Does that make sense? And where is it undefined? Wherever you have a cusp, a corner, or a vertical tangent. All right, so let's see. X1, that's a critical point. Is this critical point max, min, or neither? Max. So for now, let's put the word local max. They're all local. What about X2? That's a local min. Everything is always going to be a local. We'll talk about absolute in a little bit. What about X3? Is it neither? Yeah, it's neither, right? Because it's not a max or a min. Do you guys see that?
Well, how could you figure out X1 and max and not X3?
Because X3 to the right, I have bigger points. X3 to the left, I have smaller points. So
you're only going to get
that's what. No, it's just locally. What's to my right? What's to my left? Right. So I'm only looking at the vicinity locally. Does that make sense, guys? So I'm only looking in the vicinity. So to the right, I have higher points. To the left, I have lower points. So this one, X3, is neither. Cool? Correct. So, yeah, you're right. We're just looking in the vicinity together. I had to process what you said. Are we good?
Yeah.
All right. What about x4? Okay, the derivative is undefined, which means it's a critical point because that's what f prime if it's 0 or undefined. So this one's a local max, and we'll talk about if it's a global one in a little bit. These are all critical points. What about x5? Local min. What about x6? Neither or neither. And then we can talk about endpoints later on. Our book does mention, okay, well, I guess I'll tell you now. There are two frames of thought when it comes to max and mins. The AP exam avoids this frame of thought. Some books do not say you have a max or a min at endpoints. I do not like to believe that. Why do I say that? Because look, in the vicinity, look at what I'm circling. In the vicinity, that endpoint is a min. Does that make sense to you? So most university textbooks will say that's a local min. Most university textbooks will say this endpoint right here is a local max. Now there are textbooks, so don't freak out. If you go to one of those universities and they make you check out a calculus book by some author and that author says that you can't have max and mins and endpoints, don't freak out. Don't be, oh, Travis taught me wrong. It depends on the author and who, I guess how that author, what university they went to and what ideologies they have in their heads. Does that make sense? In my ideology, the way I see it, I don't see any other point. I see that as the highest point on the right-hand side, don't you? I call that a local max. I call it a local max. This right here on this left-hand side, that endpoint, that's the lowest point I see in that vicinity. I call that a local min. Cool? Some authors won't. Luckily for you, College Board knows the ambiguity there, and they're not going to test you. You're going to notice the free response questions, they always avoid the endpoints, and that's on purpose because it depends who the author of that textbook, what they wrote. Are we okay? Okay. Now let's talk about global. Everything is always local. Everything will always be local. But not everything is a global, max or min. Does that make sense? So global max, global min means which one is the biggest from all the maximums. Make sense? Okay, I'm looking at all of them. Do I have what looks to be an absolute max? It looks like it is X4. It looks like it just barely beats out letter B over there. So it looks like this is a global max. Everything is always local, but not all locals are globals. Does that make sense to you guys? All right. Does there appear to be an absolute min? Which one does it look like to you? X2, that's the absolute min. Are we okay? And you can also put global. They're both words that you can interchange, and I did that on purpose. Put one in global and the other one absolute. So absolute min or absolute max, you could also use the word global min, global max. Global and absolute mean the same thing. It's the biggest of the biggest or the smallest of the smallest. Cool or not cool?
And that's within the domain.
Yes. Okay, so far, everything we've done with this image, you knew in Algebra 1 and Algebra 2. I think you covered that in Algebra 1. This is a max, this is a min. Cool? All right, here is where calculus comes in. Don't worry. Look, we're going to keep it simple. I want you to notice, if you have colored pencils, this is a good place to have colored pencils. I want you to notice this part right here. Is that increasing or decreasing? So I'm going to write f prime greater than 0. Then at that local max, f prime equals 0. It's a critical point. We already called it that. And I want you to notice, I'm going to put it in green. So I'm going to use blue for increasing and green for decreasing. Notice this in green. Is it increasing or decreasing? So I'm going to write this f prime less than 0. Are we still okay? Notice this region here is increasing how do you say increasing? F prime greater than 0. And then I continue to increase after I reach that critical point, F prime greater than 0. And then I decrease F prime less than 0. And then I increase again, F prime greater than 0. And then I increase again, F prime greater than 0. And I'll slow down. Do you guys want me to zoom in on any region? What do you observe? Is there any inferences to be made? So I want you guys to, let's look at this together. We're going to read it left to right. F prime was positive, F prime was negative. I have a local max. And then look at x2. F prime was negative, F prime is positive. I have a local min.
So whenever the F prime changes sign.
Okay, so whenever it changes signs, it looks like I have an extrema, but do I have a specific type of extrema? So check it out. Look at the blue. When I go from blue to green, it looks like I have a max. When I go from green to blue, it looks like I have. So now we're starting to justify some concepts. Whenever the derivative changes from positive to negative, you have a max, and it makes sense because the derivative of positive means f is increasing, and then derivative of negative means f is decreasing. So I must have a max if the derivative changes from positive to negative. And then whenever I go from green to blue, I have a minimum, which makes sense because when the derivative is negative, f is decreasing, and when the derivative is positive, f is increasing. So I must have a minimum. Is that starting to make sense?
Yes.
Okay, don't worry. We're going to write these down in a little bit. Okay, go to the next page. We already talked about what a critical point was. So what's a critical point? Where the derivative is either 0 or what? Undefined. And then don't worry, don't freak out. If you don't understand what this means, corollary 1, it doesn't matter there. This just means if the f prime is positive, you're increasing. F is increasing specifically. If f prime is negative, f is decreasing. Now, all this means here, guys, you read a graph left to right. That's all it means. So if f prime is positive and you're reading the graph left to right, f is going up. F is increasing. If f prime is negative and you read the graph left to right, f is decreasing. Are we still okay? Okay, here we go. We're gonna draw sketches, and it doesn't have to be perfect, don't worry. You guys ready? It says, if f prime changes from positive to negative at C. So let me go ahead and sketch a little, I'm gonna say this is C, and then what's my f prime doing? Changing from positive to negative? Okay, so here we go. Positive to negative. And what did I use for positive? Did I use blue? Blue. I'm trying to keep the same color scheme for you guys. Oh man, where's my blue? There it is. F prime positive, F prime negative. Do you guys notice how we have a max there? And let's do another example where the derivative is undefined. So let's see, linear line, and another linear line. Notice that at this moment, f prime of C is 0, that's C. And then f prime positive, f prime negative. I'm trying to keep the same colors, guys. I'm trying to write good notes here. It doesn't matter if we, how the concavity, it's still gonna, if f prime is positive and f prime is negative. If f prime goes from positive to negative, you have a max. So I'm gonna write that statement. So what statement am I gonna write? if f prime changes from positive to negative at x equals c, semicolon, f of c is a max at x equals c. Hopefully all that made sense there. If f prime changes from positive to negative at x equals c, f of c is a max at x equals c. The y value is a maximum and it occurs at x equals c. That's what it's trying to say. How do we feel? Yeah, perfect. Nothing crazy. Let me know about when I can go to the next one. Okay. Here we go. F prime changes from negative to positive at c. So I'm going to do the same thing. I'm going to sketch two scenarios. F prime goes from negative to positive. I'm going to say this is c. So first I'm going to do one that is differentiable at c. And then let me do one that's not differentiable. Let me see if I can do a different one. Negative to positive. So I'm going to go, and then bam. There we go. I like it. You know what? I like it better if it's concave down, because we haven't done that. There we go. So notice f prime of c equals 0 on that one. And on that one, f prime of c is undefined. On one, the derivative is undefined. It's still a critical point. And on the other one, the derivative is 0. Because on one, I have a corner. And on the other one, I have a horizontal tangent. Yes? Let me see. Say it again. Oh yeah, I can't believe I put 0 in there. That's crazy. Yeah, that's not 0, that's undefined, guys. I don't know why I wrote 0 there. How come you guys didn't tell me? I make mistakes. I should probably outline. Okay, so what statement are we going to make about this one? If f, perfect. If f prime changes from negative to positive at x equals c, comma, then f of c is a minimum, can't spell minimum, minimum at x equals c. You feel okay? Ready for the next one? If f prime does not change signs at x equals c. Okay, let's do that. So something that does not change signs. So here's one where the derivative is 0. And let's see. Concave up, concave down. We'll make a corner. I should have done one going down. It doesn't matter. F prime is positive. F prime is positive. On this one here, F prime of C is undefined. Does not exist. What do you think we conclude on this one? If the sign of F prime does not change, there is no max min. If sign of F prime doesn't change at x equals c, comma, no max slash min at x equals c. That's better. If sign of F prime doesn't change at x equals c, no max min at x equals c. How do we feel, guys? That's always true. Doesn't matter. I made two. I should have done one where the derivative was negative, but that's fine. Where negative and negative, but no big deal. How do we feel? Okay. Now the left-hand point. Again, some textbooks will have different. Our textbook does call these endpoints max mins. So it's saying my derivative is negative for x greater than a. So what does that mean? That means I have a right here. And then for all values larger than a, my derivative is negative. So my derivative being negative means this. Decreasing. So I call that a max. Yeah. So I call this a max. F of a is a max. Well, in this case, it's absolute because they make it go down. Everything will always be a local. So if you just say max, it's understood that you're talking local. Because everything is always local. Now, not every local is an absolute or global, but everything is a local. The way I have it drawn, yes, because I have the arrow going down forever. Here's scenario 2. It's saying that a comes first, and then all my values are larger than a, and then it says f prime is bigger. So that means I have this going on. And it doesn't matter concavity. Let me do one concave down. So notice this one is a min. Fa is a min. You probably won't have to justify the endpoints, but make sure that you know why. Are we okay? At a right endpoint. So let's see. For x less than b, f prime is negative. So for all my values to the left of b, my derivative is negative. So that means I got to do this. Let me make it better. Let me just make a straight line. My derivative is negative there. So that looks like a what? F of b is a min. For all values smaller than b, the derivative is positive. I'm gonna do an increasing with a decreasing rate of change, if that makes sense to you guys. My tangents are getting closer and closer to 0 there. So there it is. This is a f of b is a max. How do we feel? Do we feel pretty good? Can we still take some more, or?
Wait, are those supposed to be f private? Oh.
No, f of b. All right. So here it just tells me, this is coming from UH, I believe. And it says find the critical numbers of f and classify the extreme values given. Notice that all of these are linear lines. So my left side derivative is not going to match my right side derivatives. Look, this derivative is -3, this derivative is 1, so I have a corner at 1. And then all of a sudden this derivative is -1. So I have a corner at 1, I have another corner at 5, so I have a critical point at 1 and 5. Do you guys see that just by looking at it or no? Okay. All right.
See what you did? I don't.
Look, don't worry. I think right now that we're rookies, I'm going to go ahead and sketch it out. But I want you guys to notice that all three of these are linear lines. So I'm not going to have a smooth transition from one to the next. I think they're all continuous. Let's see. -3 times 1 is -3, and then 1 minus 4 is -3. Yeah, they're continuous. So all three of these touch at 1 and at 5, so it's a continuous graph. But notice, this slope is -3, right? This slope is 1. So it's going to create a corner at 1, at x equals 1. Then this slope is 1, and this slope is -1, so it's going to create another corner at 5. It's like, yeah. Mm-hmm. Or I guess you can also call it a cusp, but yeah, it's like a corner. Yes. So you have critical points at 1 and 5. But don't worry, we're going to graph it, guys, because I know that some of you guys are like, what? So here we go. Let's graph it. So let me do my grid. Let's see, 0 and 9. All right, so here's my grid. And here's my graph. I'm going to do all my graphs in red. So at 0, you're at 0. I'm going to put a solid dot there. And at 1, you are at -3. So here's 1. And I'm going to say -3 is right here. And it's that line. And then all of a sudden at 1, this one takes over. So it's going to be back to solid because 1 minus 4 is -3. And I have a slope of 1 all the way until I get to 5. So I'm going to say 5 is here. It's not drawn to scale. And I'm going to say there's a 1 right there. So that's 1. So there it is. There's an equal sign. And it has the same y value. So now next, guys, I'm going to go to 9. 6 minus 9, what's that? -4. So I'm going to say -4 is down. I'm going to say 9, -4 down here. And it's going to go. And there it is. Not the best, but that's fine. So here's my graph. So where do I have critical points? I have a critical point at 1, and I have a critical point at 5. I have endpoints at 0, and I have endpoints at 9. I have an endpoint at 0 and an endpoint at 9. X equals. Are we okay? What's up, Parker? It's open, it's closed because of this one right here. It's a continuous function. Are we okay, guys? Okay, so let's see. Which one's a max, which one's a min? 5 is a max. 1 is a min. Is it an absolute min? No, I think, and I think UH agrees. We'll see the answer choices right now. I think the absolute min happens at 9. Notice that it's an endpoint. Some authors do not like that. Cool? And then at x equals 0, that is a max. It's not an absolute max, but it's a local max. So this one right here is an absolute or global. And we'll read the answer choices and see what it says. Cool or not cool, guys? All right, so let's see what it says, guys. Letter A, critical number at x equals 1. Local and absolute min at f of 1 equals -3. Local min at f of 0 equals 0. Okay, we just said that f of 1 was not an absolute because it's not the smallest y value. So letter A is out. We have a smaller y value. 6 minus 9 is negative 4. Letter B, no critical numbers, no extreme values. Take that one out. That's just ridiculous. Letter C, critical numbers at 1 and 5. That's true. Local and absolute at f of 1 equals negative 3. Okay, we're going to question that. Local max at f of 5 equals 1. Uh-oh, did I mess up?
So how did you get like the absolute minimum?
I think I made a typo here. Because f of 1 cannot be absolute minimum, and then it says absolute minimum of f of 9. There can't be two absolutes.
What is the absolute minimum?
Absolute minimum is the smallest y value on that interval, period. No, there's a smaller value. This one's smaller. That's negative 4. Oh, 6 minus 9 is not negative 4. Man, I'm way off today. No, that's not okay. But thank you for being nice. Man, guys, how come you guys didn't tell me? That 6 minus 9 is negative 3 and not negative 4. This changes everything. We'll slow down. I'll slow down. I got plenty of sleep, too. That's the scary part. All right. Let's start. You okay, Ortiz? Okay. Let's start again, guys. If you have two numbers that are tied for the same, then you're going to call those both absolute. So that's the only exception that you can have more than one. So why can I have more than one? What's my y value on this one? Negative 3 at x equals 1. Yes or no? What's my y value at 9? Negative 3. Those are both my lowest points, right? So both of those are absolute min. Does that make sense? Okay. Then everything is absolute min, absolute max. Well, I guess that's the other exception, I guess. But yeah, cool. All right, here we go, finally. Letter A, let's go back through all of them. Critical numbers at 1, but what about 5? Local and absolute min, f of 1 equals negative 3, yes. Local min, f of 0 equals 0, no, that's a max. So A is still out. B's out. Okay, letter C. Critical numbers at 1 and 5, yes. Local and absolute min, f of 1 equals negative 3, that is true. Local max, f of 5 equals 1. That's also an absolute max, but that is a true statement. So let's see. Absolute min, f of 9 equals negative 3. So far C looks like it's going to be the correct one. Let's see what D says. Critical number, 1 and 5. Local and absolute min, f of 1 equals negative 3. Local and absolute max, f of 5 equals 1. And absolute min, f of 9 equals negative 3. Okay, there are actually two correct ones, but the more correct one is which one? D. I hope that UH doesn't do a whole bunch of those, because I think that's kind of trickery, because every absolute max is also a local max. But D is more specific. Not only is it a local, but it's also an absolute. Does that make sense? Say it again.
So it says, how come it doesn't call like f of 9 local and absolute? It just calls it absolute.
That's a good question. Maybe probably because it's an endpoint, and they're like, oh, let's not. But it's also local, in my opinion. But different authors, different universities treat endpoints weird. Does that make sense? So they might be treating it like that because it's an endpoint. Yeah, I can email Dr. George because she used to be at UH for a long time. So I can email her and be like, yo, Dr. George, what's up? Oh, actually, she liked one of my comments yesterday. So, okay, anyways, I posted something on Facebook and she like. So anytime a professor like Dr. George, I'm like, okay, anyways, I'll stop. I like Dr. George. She's really cool. All right, guys, let's keep going. We're almost done. Yeah, the rest are easy now. Are we in example 2? Okay. For what values of x does the function have a relative max? If you have a calculator, you can just look it up, but we don't have a calculator. So we're going to have to find our critical points. So how do we do that? Take a derivative and equal it to 0. So here we go. F prime, we got to do product rule. So I'm going to underline and double underline first times the root of the second, 2x minus 3 to the 1 power times 1 plus second times derivative of the first. So there it is. I'm going to equal that to 0. You're done with calculus. You're now doing algebra. You guys ready? I see an x minus 3 that I can factor out. Yes.
Don't you have to find the derivative of the inside as well for x minus 3 squared?
Yeah, the derivative is 1, no?
Oh, you're right. My bad.
First, times derivative of the second, plus second, times derivative of the first. Yeah, I think I did everything okay. F prime of x equals, now we're just doing algebra, guys. X minus 3, and then you're going to have 2x minus 4 plus x minus 3. I have a product here where I have an x minus 3, and I have another x minus 3. I got 2 of them. So I factored out 1x minus 3.
Oh, okay,
Yeah, I have an x minus 3 right here, guys. And it is all a product. And I have another 2x minus, I have a x minus 3. I got 2 of them on this side, right? If I have something like ab squared or ab plus b squared, I can factor out a b, and it'll be a plus b. So that's all I did, right? Okay. I distributed to 2. 2x minus 4. Okay. So here we go. I have this x minus 3, and then 2x plus x, that's going to be 3x, and then negative 4 minus 3, 4, 5, 6, 7, minus 7. Okay, I got... Yeah. It says squared there. I took this x minus 3 out, and I took one of these out. We still okay? All right, I got 2 critical numbers. X equals 3, x equals 7 over 3. Those are my only 2 possible answers that I can have. These are just candidates. If it is not 3 and 7/3, take it out. Out, out, out. Oh man, I guess I gotta do better about making sure you can't just guess. This one you can just guess. It's gonna be letter D. I'm gonna do my railroad tracks. What's up, Castillo? I know, that's what I should have put it. I should have put a 3 in there.
No, but which would be?
Yeah, we're about to figure out which one it would have been. So I'm gonna put the number 3, and then 7 over 3 is a number smaller than 3. Do you guys agree? Okay. Notice that I put F prime. You don't care about the output, you just care about positive or negative. You guys ready? If I choose a number like 0, so 0 minus 3 is negative 3, 0 minus 7 is negative 7. Negative times a negative is a positive, so that's a positive. So in case you don't know, 7 over 3 is like 2.33. So I'm going to choose a number like 2.5. And you don't make it hard, guys. You don't have to figure out what the actual number is. You just care about positive or negative. 2.5 minus 3 is a negative. 3 times 2.5 is going to be a number slightly bigger than 7. So it's going to be negative times a positive, which is a negative. Now I'm going to choose a number bigger than 3, like 5, or any number, 10 for that matter. So if I put 5 minus 3 is positive. 5 times 3, that's 15, minus 7, that's another positive. Positive times a positive is a positive. All right, now we can analyze this function. I have a max whenever my derivative changes from what to what? Positive to negative. Where is it changing from positive to negative? 7 over 3. You read a graph left to right. Cool or not cool? Okay. Yeah, next time I'm going to make sure. Huh?
I think I need to do a lot of practicing with that because what we did make sense, I just don't think I
Okay, we'll do a lot of these. A lot. Don't worry. We're going to do so many, you're going to get tired. You're going to be like, I'm done. I'm exaggerating. I hope you're not like, are we good? Sorry, miss. Find the intervals on which this is increasing. If you had a calculator, of course, we could just type it in and see where it's increasing. We're going to find where the derivative of this is greater than 0, positive, perfect. So here we go. Let's find critical points. F prime equals, what's the derivative of 7x to the fourth? 7 times 4? 28, x to the third, plus, and I'm going to equal that sucker to 0. You're done with calculus. Now it's just algebra, guys. What's the biggest number I can factor out? X squared, and does 6 go into 28 and 12? Does 12 go? 4. 4x squared. How many times does 4 go into 28? 7? 7x plus 3. Close equals 0. I get 2 critical points. Did I mess up? Yeah, no, I think we're good. I get 2 critical points. X equals 0. X equals negative 3/7. I'm going to do my number line. Here's my number line, or railroad tracks, whatever you want to call it. I'm going to call this F prime. And I'm going to put negative 3/7. And I'm going to put 0. Matter of fact, you don't even have to pay attention to the 4x squared, because the 4x squared is always going to be positive. So really, we just have to pay attention to this. So if I choose a number to the left of negative 3/7, like negative 1. 7 times negative 1 is negative 7. Negative 7 plus 3, negative number. Do you guys see that? If I choose a number like negative 2/7, which is between negative 3/7 and 0, then the negative 2/7 times 7, that's going to be negative 2. Negative 2 plus 3 is going to be a positive. And if I choose a number bigger than 0, like 5, then I'm going to get a positive again. All ready? Okay. You might get confused here, but I'm going to try to see if we can, I'm going to try to go really, really slow. This is a continuous function everywhere. For a moment, you do have a horizontal tangent. At x equals 0, you are flat, but you actually increase. So to answer this question, where am I increasing? F is increasing on interval negative 3/7 to infinity. I'm not trying to explain it, guys. I'm not trying to explain it. Because some of you guys might be tempted to do this. Negative 3/7 to 0, union 0 to infinity. This is okay. This is better. You can put bracket. You can put bracket. They won't penalize you. Parenthesis or bracket's fine. That's your starting point. All right, you guys ready for this? Why is this one better than the one above?
It's still increasing even if it has even if it's not differentiable, it doesn't.
Yeah, let's talk. Yeah, I think you guys kind of got it already. Because guys, the definition of increasing is that the pixel to the right is larger than the pixel. Like if I zoom in right here, see how it's flat? At that moment, I know that I have a horizontal tangent. But the pixel to the right is still larger than the pixel to the left. And then right here, if one pixel to the left, well, this pixel here in the middle is still larger than the pixel immediately to the left. Does that make sense? So even though at 0 or at 0, you have a horizontal tangent, this is your best answer because you are technically still increasing on that entire part. Cool or not cool? Now be careful because sometimes they'll trick you and there'll be a vertical asymptote there. And only if the function is continuous. What's up?
Okay, so is it like technically like the other one, like that one is kind of saying that it's discontinuous?
No, because this is a continuous function.
No, but like, so like we cancel that one with the
Well, you probably won't see this in multiple choice. If you did, they're really mean. I don't think this one will come out in the multiple choice. It would be this answer that you would see. I remember one on the 2008 exam. We'll see if we can find it. You know what? We might just look for it right now in a little bit. Do you guys still have your 2008 exam? I'll look for it in a little bit. Don't worry, we got 2 left. Or do you want to finish these 2 later? So that way we can look at the AP exam. All right, so I'm going to pause it right here, guys. All right, you guys ready for the next? Example 4. So this one says, find the intervals on which this function is increasing. So all we know right now is 2 basic rules. Well, we know several things, but in terms of derivative, if f prime is positive, this means, I guess I should put a bullet. F prime is positive, this means f is increasing. Perfect. F prime is negative, comma, that means f is decreasing. And I should write better math notes. I should be putting left to right. You always read a graph left to right. Just like you read a book, left to right. Now there is a country where you read up to down and right to left. What is that, China? Or okay, up to down. And then which one's the one that's right to left? Is it Arabic? See, I don't know which one. So, but yeah, you always read a graph left to right. Okay, find the intervals on which this function is increasing. So we got to take a derivative, and we got to see where we're going to find critical numbers, and then we're going to see where my derivative is positive. Do you guys see the game plan? All right. By the way, this does not have any vertical asymptotes, so we are safe. No vertical asymptotes. It looks like it is a continuous function for all x's. How do we know that? There is no x value that in the denominator that will give us undefined. There is no x value that will give us a negative, that will give us a 0 in the denominator. The denominator is always positive. Yes, correct. So here we go. F prime. I have to do what rule? Quotient. Bottom. X squared plus 49 times root of the top minus top times root of the bottom all over bottom squared. Are we still okay, guys? I'm going to equal this to 0 to get a critical point. Are we still all right? I do not care about the denominator. I know the denominator will never be 0. I start focusing all my attention to the numerator and doing algebra. Are we still okay? All right, so let's see. Let's make life simple. I see a 6 here. I see a 6 here. Can I factor the 6 out? Yeah, so here's my 6 factored out. I'm going to have x squared plus 49 minus 2x times x. 2x squared. Do you guys see that? Now let me know if I make mistakes. I make mistakes all the time. And remember, that's what we're setting equal to 0. So let's see what this is. 6 parentheses 1 minus 2x squared. That's going to be a negative x squared. Negative x squared plus 49. Okay. So now there is 2 numbers that will give me a 0 for this expression. If x is equal to what? 7, or if x is equal to negative 7. Because you keep the negative there. Negative 7 squared is 49, but that negative in the front stays there. So negative 49 plus 49, 0. Yeah, or difference of squares. Are we still okay, guys? All right, next, here's my number line. I'm going to write f prime, and all I care about is those 2, negative 7 and 7. They wanted to know where I'm increasing, so I'm going to put values to the left of negative 7, in between negative 7 and 0, and 7, sorry, and then a number larger than 7. All I care about is the sign. You don't care about the actual output. So let's see. If I choose a number like negative 10, negative 10 squared is 100, but there's a negative in the front. Negative 100 plus 49, that is a negative number. If I choose a number like 0, because that 0 is between negative 7 and 7. 0 squared is 0 plus 49, that's a positive number. And if I choose a number larger than 7, like 10, again, I get a negative number. Yay or nay? Okay. So, what do they want? Find the interval which this is increasing. I'm going to write f is increasing on the interval negative 7 comma to 7. And I think technically I should be putting brackets, but I already got used to parentheses. This is not a point, that's an interval. I said it with the word interval there. Cool or not cool? Okay. How do we feel, guys? All right, so I feel like we should have done example 5 yesterday because I think I saw some of the homework, so you guys got it wrong. Before I start this question, what am I looking at? Is this F or F prime? This is F. Always ask yourself that. So now it says, it wants to know, sorry, I see a mosquito here. I think it's a fly. It wants to know where F prime is 0, positive, and negative. So let's first do the 0 one, because that's pretty simple. So F prime is 0 wherever I have horizontal tangents. There seems to be 2 locations. Where and where? Perfect. -1 and 1. Do you guys see how you have horizontal tangents there? So I'm going to write F prime is 0 at x equals -1, comma 1. All right. What color did I use for positive slopes? Was it blue? Okay. So blue. Look where I'm putting blue at. How do I know that F prime is positive in those two locations? That is where what is increasing? No, not slope. The F. That's where F is increasing. If you say slope increasing, that means F prime is going up. Yeah, we're gonna talk about how to say things correctly. F prime is positive in these 2 locations because that is where F is increasing. Now be careful. I can tell. Okay, this is where everyone too, not just college board professors do. They want you to be very specific with the language. So I'm gonna say again. I'm gonna repeat it. What they want you to say. This is where F prime is positive. How do we know that? Because this is where F is increasing. Does that make sense? Avoid the word it, because that's a very common mistake that we do. F prime is positive because it is increasing. Well, what is it? Does that make sense? So what is it? F. So make sure to very specific language. I'm going to write F prime is positive from -infinity, comma, all the way to -1, union, and from 1, comma, all the way to infinity, since F is increasing. On, oh, sorry, go ahead. On these. Yes, that is specific language. The graph of F has a positive slope between -infinity and -1, and 1 to infinity, since F is increasing. But the best one is to say F prime is positive. Now be very careful. If you say the slope is increasing, listen to what you're saying. If you say the slope is increasing, what you really are saying is that F prime is increasing. Now, we haven't talked about the second derivative yet, but I want you to just focus. Notice that I'm changing from positive to negative. So my F prime, if we're talking about F prime, this is just to get it in your head real quick. If we're talking about F prime is actually decreasing. I'm talking about F prime, not F. Because the slopes are getting, like it was negative, like let's say it was 10, it was 5, it was 3, and I'm approaching 0. Do you see how F prime was like 10, 5, 3, 0? So
it's sort of like decelerating.
Yeah. So be careful with the words. So F prime, don't say F prime is increasing, it's not. F prime on on this one it is. F prime is increasing there, but on this one on the left, F prime is decreasing. Does that make sense? That's just for you to look into the future. We're actually going to talk about it today, but we have a few that are absent, so I decided that's important enough that we'll talk about it later. Well, I guess we just did right now, right? All right. And then I think I used green for F prime negative, right? All right. So this in green, F prime is negative. Why is F prime negative there? Perfect. F prime is negative from -1 to 1, since F is decreasing on this specific interval. this is how I talk, so this is how I write. But you do gotta, and I know it sounds funny, like f prime from -1 to 1 since f is decreasing. F prime is negative from -1 to 1 since f is decreasing. A lot of you think maybe that's enough, and it might be, but when the day of the exam, when they tell us, like, they give us a rubric, and that rubric is very detailed, and that rubric usually says tie it back to that interval. So instead of me saying from -1 to 1 again, I just like to say on this specific interval, because I already mentioned it. You know what I mean, guys? So this is how I like to chat, and this will be full credit. Cool or not cool? Okay, so let me go ahead and stop this here.